So traceability. So for us, traceability means accountability. It means being able to retrace which units of a given load were shipped to a customer, but also the origin of all the material used to produce that load. It also means knowing the name of the employees who were working at the factory while this load was being produced. So we know basically everything about that product through our traceability system. This is an essential part of our quality control system, and it makes it easier for us to find areas of improvement and to monitor the solutions that were implemented. So that basically encompasses a lot of all of Berger. It means we can look at product codes, which allow us to look at the quality control for those product codes. We can backtrack the products we used or that were shipped to customers, also the components that were used to manufacture those products, and we can even pull the warehouse samples that we keep for a full year after we make a production. So reading the product code is very simple. If you look at a tower, a skyscraper, or the 3.8 bales, you have a unique product code on each of those units. The first 5 numbers are basically specific to that product. The following 2 numbers are actually the bagging format. So 99 is the skyscrapers, 38 is the 3.8 cubic foot bales, 03 are the loose-filled 3 cubic foot loose-fill bags. And then after that, we have the Julian date of production. In this case, it was day 234, which would be, I guess, somewhere in July. 14 is for the year of production, 2014. The following number is actually the unit number, so the 24th unit which was produced. And then we have our production facility. 05 is actually Baie Sainte-Anne in New Brunswick. And then we have the production shift, work shift. 1 is during the day, 2 is during the evening, and 3 is during the night. So all this is basically unique to each production that we make. Well, actually each unit that we make. For the 3.8 cubic foot bales, which you do receive, you have that on each bag. So we have quality control checkpoints before, during, and after production, and that guarantees that Berger has all the information we need to manufacture high quality products. So before the production, all the components are characterized and every new load or batch is tested before production. During production, the products are tested during the manufacturing process, and that allows us to do some real-time adjustments during the production. During the production, we're actually testing for pH, we're testing the EC, we're testing the particle size, we're testing the water content, and we're also, for the bagging system, we're testing the weight of the units, we're testing the weight of a cubic foot, which allows us to measure the volume per unit. So, and I'm missing something, I'm sure. Density is also tested during production as well. And after production, well, we test whatever really doesn't have an impact during production. So we know that that's going to be fairly stable. The testing that's done afterwards is just to confirm that everything's good. One thing to mention, we have 1 minute and 20 minute pHs which are tested during production, but after production we have the 1 day, 7 days, and 30 days, which the 7 days is really the one we base our acceptance or non-conformity on. So we use the 1 minute and 20 minute values to make real-time adjustments during production, but it's actually the 7-day pH which will confirm that the product is good to be shipped. For each production we have, depending on what the size of the production is, we take 1 sample per 1,000 cubic feet that's being produced approximately, and that is, well, we do our regular testing with that, but a subsample of that is sent to our warehouse for storage for a full year. So thanks to our traceability system, all the information concerning a specific product can be will track back to its original components and to the production, basically, of that product. So for instance, if we look at this report right now, which is the product tracking for Southwest perennials, we see that if we have the invoice number, the bill of lading, the order number, or even the delivery date, we can actually figure out which load of material was shipped to that customer at that given time. If they're looking at a unit that they still have in inventory, they can just read the product code to us and we can track all that information back to what we actually shipped to them. So all we really need is any of those information and we can actually do an investigation on the product that was manufactured. We can also provide a volume chart which gives the information as to how much volume was in each unit that was shipped to a customer. This is actually an example of a volume chart. So you have the production code, the Julian date of production, and you have the individual skid numbers with the volume that was within each of those skids. So this was actually some BM4 NF wood which was shipped to Nash Greenhouse in 2014. Just a closer view of that information. Also, another thing we can provide are the final inspection reports. So all the testing that we do for the quality control are actually can be reported in a final inspection report, as we can see right here. So what we have here is the results for the SME analysis, so the EC, electrical conductivity, and basically the parts per million of each macro or micronutrient that's added to the product. In the case of GrowTech, most of the products don't have any fertilizer, but we do have some products that we manufacture for you that have special fertilizer, in fact. So this is information we can provide that can be useful for you on your side and also your final users. We have also the incubated 7-day pH, which is what, as I mentioned earlier, we base our target range for the acceptance or not, and also the particle size, which is very important in terms of the physical characteristics, how the product's going to react in the greenhouse, and the water content of that product as well. Now, if necessary, if a customer's having an issue or if he just wants some additional information, we can also provide that information. It's information that's not necessarily indicated on the final inspection report because it's not information that's going to have an impact on whether the product is authorized or not for shipment, but it's information that we do keep. For instance, we do 1-day and 30-day incubated pH. The 1 day is basically to let us know in advance if the 7 days is going to be good. It's especially practical for our standard products where we can do some just-in-time deliveries. We're used to manufacturing this product, so we basically have a better idea of how it's going to react after 7 days. So by looking at the 1-day pH, we can already figure that it's going to be good after 7 days or not. If not, we'll wait until we have those 7-day results. But if we feel comfortable with the 1-day result, we can pre-authorize it for shipment after 1 day. We can have also the full particle size analysis. We saw in the FIR it's just a number 10 sieve, but we can also look at additional details in terms of the larger chunks, but also the finer material that was present during production. The stick content as well, which can be critical for some users. In the case of GrowTech, it is because of your manufacturing system. You have it going through a sort of a small tube, and when you're adding the polymer, and if there's too many sticks, which we did have an issue in the past, but we corrected that, that is very important to you. The wettability is the opposite in your case because we're not adding any wetting agent to your product. So the wettability really, when you're not adding a wetting agent, well, you're going to have wettability that's not acceptable in terms of our regular growing media production. But for other customers, that is very important. And also the density, as I was mentioning earlier, which is tested at the factory. Now, each production, we also have the factory which produces a production report. That production report has a lot of information that is compiled during the production. So we basically have all the inputs that were added to the growing media. So every tower that is fed to the factory to produce the growing media is actually scanned before it is loaded into the factory. So if we look at the production report, we can actually look at all the individual towers that were used to produce that product. When I'm talking about towers, I'm talking about, for instance, BP coarse in terms of a horticultural mix or BP fine in terms of a seedling mix. We can look at each skyscraper that was used to manufacture that product. We can also look if there were any downtimes during that production, what was the cause of that downtime, how much time it lasted, which employees were working at what position, who was taking the PHs during the production, who was looking at the packaging section, who was making adjustments there, who was the person who was loading the towers of peat into the factory. We can look at consumption statistics to make sure that the amount of peat that we were theoretically supposed to use to get to the final product is within an acceptable range. If it isn't, then obviously we're going to have to take a look at the final product to see if it did have an impact on that final product. And also, if there's anything that happened during production that was out of the ordinary, the employees have instructions to write that in the production report. So for a given production, if there's an issue, that's other information that we can look at to see if we can't have an idea of if there was a problem with the product, what went wrong. The report actually has more than one page. I didn't include all the pages. This is actually just the first page. So you have actually here the types of skyscrapers that were added to the product, to the factory to produce the product. Here's the perlite. So it's basically the raw material feeding right here, the product that we were manufacturing, how many we manufactured, and in the further pages you'll have the complete list of the towers that we used, if there were any consumption differences with the fertilizers, with any component basically. So a lot of information on there. So as I was mentioning earlier, we also test our components. If we get a new batch of a given fertilizer, or if we manufactured a new batch of perlite, we have quality control that's done on those components. So if we're looking at the production report and we don't see anything that's really out of the ordinary and we want to look further, we can actually look at the final the certificates of analysis for the quality control that was done on those components, on the individual components. So not only that, we also keep samples for 1 year of those components to make sure that if there are any issues, we can pull those samples out and investigate further if needed. So just as an example, if we look at the BM6, all the pre-production testing that's done on the components, we have the peat moss, which is harvested in our bogs. We'll have some particle size testing, we'll test the density, we'll test the water content, we'll also test the stick content. And then, for instance, for BM6, we're also adding perlite. So for the perlite, we're testing the particle size, we're testing the expansion factor, and then the limes that we're using, we're buying that in. Each load that we get, we'll test for neutralizing power, carbonate content, particle size, water content, efficiency. Now, we test that because for every component that we use in a growing media that is supplied to us by a supplier, we have certain ranges of acceptance. So before we accept a load that's been delivered, we'll run tests on it to see if it falls within the specs that we've established for that product. Our solid fertilizers, it's the same thing. We use many different solid fertilizers in our production. In the case of the BM6, we have basically 6 different fertilizers that we're using: calcium nitrate, magnesium sulfate, chelated iron, potassium nitrate, triple superphosphate, and fritted trace elements, the FTE. And all these products are also tested when we get a batch of each to make sure that they fall within specifications for that product. From those solid fertilizers, there's actually 3 of them that we actually dilute in water for the application. It makes it much better application, much more uniform. That's the calcium nitrate in one batch, and we have a separate batch of magnesium sulfate and chelated iron. We don't add them all together because the calcium nitrate would react with the 2 others to actually form a precipitate. But the batches of liquid fertilizers that we prepare on site are also tested to make sure that we've basically followed the recipe correctly and the results are within the specifications that we've determined. Same thing for the wetting agent. It's also diluted in water. It's a very viscous material, and if we were to try to pump it through our pumps with a pure wetting agent, our pumps would just break every every minute. So we dilute it to between 9.5 and 10% in water, and that's how it's added. So as you can see, a lot of testing is done, and that's just pre-production. So as I mentioned earlier, we take warehouse samples, and those warehouse samples are very practical when we have any issues with customers. For instance, when we have customers complaining about weeds, which is something that, regardless of all the prevention we do on our side and all the education we do with our customers, we know that our products are weed-free. I mean, a peat bog, the nature of a peat bog, it's an acidic environment. Weeds just don't grow there. And we take all the precautions when we're harvesting to make sure that our peat piles are covered, and we actually package our peat as quickly as possible once it's harvested. So from all the different weed tests we've done over the years, and we do some every year, we've never had any weeds come out, but we get weed complaints every year. And that's just because weeds are everywhere. So the good thing about having these warehouse samples is that when we do get those complaints, we can pull those samples out, run the weed tests, and demonstrate that our products were weed-free. Another, with the particle size, this is actually pretty important because we do get complaints on particle size, and although we have all the reports that indicate that the particle size was fine, we still have customers who, would like a second opinion because the particle size that they're observing isn't what maybe we've reported in our FIR. In that case, we can send that out to an external lab for them to do the testing. But most of the time, it turns out that by sending somebody in to look at the way they're set up with their potting equipment, a lot of times it's the potting equipment or the bale breaker that's actually causing excessive damage to our product. And we actually send in one of our experts who can actually help them tweak their machinery and find solutions to minimize that damage to their product. So our traceability system not only allows us to make appropriate decisions for many aspects of our operations, but it also allows us to easily and rapidly investigate and correct any issues that can occur. Combined with our quality control, it allows us to constantly improve our production and offer products of the highest quality.